All right, let's get started. All right, so you have an assignment due tomorrow. You can take an extra day if you want, use one of your late days. Remember, the next assignment won't come out until will be due for 3 weeks because of fall break in the midterm. I posted the sample midterm in the schedule somewhere. I forget exactly where I put it. I will eventually post a solution to the sample midterm, but I want you to have some time with it before I do that. Are there any questions or problems I could answer before we go any further? Yeah?
I just want to check how many late days do we get?
Well, to check how many, you get 4 late days, and you can go look and see how many you entered in late. Yes?
When I did PS6, I found like the pie chart, there are several blocks near the pie chart, but the pie chart has 2 Utah. Is that right?
The pie chart has what?
2 Utah. I think the parameter is the summary map. You shouldn't have two like the same key, right?
Okay, so you're saying in the example I gave you there are 2 Utahs?
Yeah, I think it's a mistake.
Okay, that could be. I just wrote that.
Okay.
You know, I hard-coded it is the word for it. So yeah, there may be mistakes. I may have put the word Utah twice. So don't worry about that. That sample code was just to show you how to use what graphics calls you need to create pie charts and bars and such. You have a question?
Yeah. In your code here, it says that if there is an illegal argument exception whose message explains what's wrong, is it saying that illegal argument is enough to explain what's wrong, or do you want us to like have a dialog box come up and like this is a negative number?
All right. Let me repeat the question. All through my specification, it says, you know, if thus and such happens, throw an illegal argument exception whose message describes what happened. That does not mean to pop up a window. It means that when you construct the exception, when you create the new illegal argument exception, you pass in the reason as a parameter to the exception. That way, when that's called, there's a method called getMessage that'll extract that message from the exception. So whoever catches it can, if they wish, display it at that point. But when you're implementing those methods, it's not your job to bring up a console, any kind of window to display the message. You just pass it in as a parameter to your constructor, your exception constructor. Yeah?
So when we're writing our test cases, do you want us to do something with that message, or just see that we get an illegal argument exception?
Yeah, so he's asking, do you need to test to make sure that there is a message that was sent in? You can if you wish, but that's sort of beyond the call of duty. There will be a message. It'll be an empty string. So the best you can do is check to make sure that the message carried by the exception is not the empty string, but I don't expect that. So, yes?
You said you wanted us to make test methods if we make any helper methods, right?
Yeah, you should have test methods for any helper method or main method, whatever, that doesn't, I didn't mean to say main method there. Helper method or the methods I ask you to do as much as you can. The method that actually writes to the graphics, you know, does the graphics, that's hard to test with a unit test. So I don't expect you to test that. Yeah?
So with the message for an error, do you want us to have the message dialog or just to print the console?
Okay, so the question is, if there's an error and there's an exception thrown?
Yeah, you want the message.
Okay. Do we want to print the message to the console or have a pop-up? All right, who could answer that question for me? Yes?
Neither. We're supposed to set the message to the exception when you create it.
Right. Very good. Okay. Any other questions? Yes?
Do the graphs have to look exactly like yours?
All right, so she's asking, do the graphs have to look exactly like mine? Well, no, they don't have to be bit per bit the same. There ought to be a pie chart and bar graphs, but as long as, you know, it looks roughly like mine, that's okay. Question always comes up because of round-off error when you're deciding how big to make each wedge. Inevitably, you draw some wedges, And then there's a little sliver that's the background color because of round off error. It didn't quite fill the 360 degrees. And people ask what to do about that. I'll just answer the question. There are two things you can do. What I did in my example was the first wedge, I just draw the entire circle the color of the first wedge. And then I draw the other wedges on top of it. So that there's no gap then. And the first color shows through. The other is when you draw the last wedge, round the amount up so you get a total of 360. Keep track of how many degrees you've drawn for everything else and just draw the leftover with the other wedge. Okay. Any other questions? Okay. Now, we started last time a new topic, and it's a big topic. The problem of creating new classes that provide new types of objects. So let's just talk about this for a minute. Going back to what we did in the first part of the course, why do programmers create new static methods? Why did we study that? What's the point? Why would you ever need to have a new static method? Yeah?
If it's something you're going to use again and again and again, you only want to type one line of code.
Okay. So basically, if you have some computation or some action you want to carry out, and it involves several steps, and you're going to do it multiple times, it makes sense to write it as a method. Then you've got it written, you can test it, package it up nicely, give it good comments, and you're done. And you can call it over and over again from this program or any other program. So whenever there's an action you need to do, or computation you need to do, that is not provided by the Java library already, you think about doing a static method and then using it. When people write large programs, I've said this before, they spend most of their time creating the parts. They figure out what parts they need, they create the parts, and then they combine the parts to get an overall program. So keep bearing that in mind, why would you ever want to define a new class that defines a new type of data? Like last time we did coordinates. Why would you ever want to do a new class?
If you need an object that you're going to use over and over again.
Okay, so he said if you need an object you're going to use over and over, if you need a new type of object, it's sort of a circular question, circular answer. The bottom line is the parts from which programs are built. There are two things. Think about your programs. What aspects of the Java library do you use? Sometimes you use built-in static methods, like square root. Sometimes you use built-in classes, built-in objects, like scanner or ArrayList. Sometimes you need actions. Sometimes you need things. To write English, you need a verb and a noun. Right? But static methods are the actions, the verbs. Objects are the nouns, the things. So it's just another kind of part that people build programs for. So keep that in mind. We're going to finish up the example we did last time with that coordinate class. I had you play with it a little bit in section yesterday, so hopefully you're a little more familiar with it. And then we're going to look at a couple more examples of what it takes to create new types of data. Okay, so here's our class. Let's start right here. Our class consists of these private instance variables right there that I've highlighted. What's the importance of those? What is the point of declaring those variables? Okay?
They're the instance variables.
Okay, so they're the instance variables. Someone tell me something else. Yeah?
Can't they be analogous to memory?
You said they're analogous to memory.
Remembers data.
Okay. Meaning, when you create an object, when you create a new coordinate, a coord 5 in this case, when you create a new object of that type, a place in memory is created to store such an object. And that place in memory has room to store each of the instance variables. It has a room to store latitude and longitude. So in other words, this coordinate object has room for 2 doubles. When you write a class like this, have you created any Objects, just from the point, you declare the class. Do any objects exist at that point?
No.
No. And that causes people concern because they see there are two variables declared there. Where are those variables stored? Yeah?
Where the class is stored?
Well, the information about the variables is stored where the class is stored. But the important thing to realize is writing the class and compiling it does not create a memory location called lat or memory location called lon. That only happens when you create an object. Every time you create an object, you get a lat and a lon for that object. You create another object, another lat and lon. Okay? So you can think of this more as a blueprint than anything else. It just says when you create an object, this is the stuff that goes inside it. These two instance variables go inside it. And that's how Java knows how big to make the object, so there's room for these two things. All right, here is the constructor. Now, the first part of the constructor, those two if statements, they're pretty familiar. You know, you see, you've been writing stuff like that for a while. We're just checking to make sure that the two coordinates are in the proper range to be latitudes and longitudes. And then we initialize the instance variables. So we're storing two numbers into lat and lon. Where? I said before, lat and lon don't exist right out of the box. So what lat and lon are being stored? Where are those numbers really being written? Yeah?
The stored as part of the object that was invoked.
Okay. To call a constructor, in your code you have to say new chord 5 and you give it 2 parameters. So the new part allocates the memory for the object. Then those last 2 lines of code right there actually store the numbers into the object wherever it is. Okay? So this is often called the implicit parameter. It looks like chord 5 takes only 2 parameters, lat chord and lon chord. But it also takes a third parameter that's called this. That's a keyword in Java, this. This, in a constructor, this refers to the object that we're constructing. The object on which the constructor was invoked. And you can see that because actually lat right here is shorthand for this.lat. And lon is shorthand for this.lon. So what you're really doing is you're setting the lat field in the object that this refers to. And you're setting the lon field in the object that this refers to. And this refers to the object that was just created by the new. So you say new chord 5, the object is created, it's uninitialized, and that this, the reference to that new object is called this inside the constructor. So it's optional. You don't have to say this.lon. That's why it's implicit. It's just implicit that we're referring, if you don't otherwise qualify lat and lon, you're referring to lat and lon from the object that's being constructed right now. Okay? Now, here's a method that gets the latitude out. So, how would this method be invoked? What would be a situation? Let's say you've done this. You say chord 5, C equals new chord, 2, 3. It's like in the ocean west of Africa, I think, near the equator. And then you call some method like c.get latitude.
Joe.
Yep.
Scene.
Oh, I won't be here for long, so I'll just leave this. What does that? No, I'm not that, but up there, the lat in get latitude. What lat is it referring to? Yeah.
The lat that was passed through the parameter when you created the object C.
Well, there's a, yeah, that's one way of putting it. There's a tighter answer I'm looking for. Yeah.
This lat.
Well, That is true. Actually, lat here is just this dot lat. So the question comes down to is what does this refer to? In a method, this refers to the object on which the method was invoked. Now, on which object was this method invoked?
C.
C. So when you call getLatitude this way, C and this refer to the same object. And so when you go and get this dot lat, you're getting lat out of C. Right? That's the thing to keep in mind. It looks like there are no parameters, but there's always the implicit parameter, the object on which the method was invoked. Yeah?
I remember you saying last class that every class by default has a two-string method. If we wanted to make one for ours, do we just declare it like any other method, or?
Okay. So we ask about two-string methods. So by default, there's a two-string method that returns something that's not very interesting. But what we're looking at now is a two-string method that I wrote. And this replaces the default one. So it has to be a method. It's called toString. It returns a string. And I just decided if someone asked me to print out or to turn a latitude a coordinate to a string, I would have a square bracket and then the latitude number and then a comma and a space and the longitude number and then a square bracket. And now anytime Java needs to convert a coordinate to a string, it'll call this method. Now, I'll tell you a little trick. It's not required by Java, but it's sort of a good idea. We are replacing the default implementation of toString with one of our own. And, oops, if you just put this little annotation, what you're saying is I'm overriding the default implementation of toString. And the reason that's good is maybe you messed up and you spelled it wrong. Maybe you forgot to make SB capitalized. And you think you're overriding it, but you're not. So what it's going to tell you here is you say you're overriding a method, but there is no existing method called toString. That's a clue that you did something that's not quite right. So it's just a sanity check that you're doing what you think you're doing. But we'll talk a lot more about overriding methods later in the course, probably in November sometime. Okay? So I'm about to change examples. Before I do that, I want to see if there are any last questions. Okay. Let's look at my list right here. All right, so the idea is we've got this new class called myList, and I want it to behave sort of like an array list of integers. So this isn't a class that we would need to implement or want to implement because there's already such a thing in Java. But for a classroom example, it's good because you already know how the methods are supposed to behave. So these are the methods I want. I want to be able to create empty myLists with the constructor. You got a question?
Okay, so when you constructed that new codified, the C, is that supposed to be new codified 2 and 3, or is there, do you have a method of codified?
Oh yeah, yeah, it should say codified. All right, so this new class myList, I want to have a couple constructors. I want to have add method that adds to the end of the list. So we add a 15 and then a 7 to a different list, to list 2. And then we add to 20, we add to 2, and so on. So we can add. We can do a get. So we can say, give me whatever stored at index 0. We can do a set. Change what's stored at index 0. We can find out how many elements are in a list, and we will be able to remove the last element of the list. So we can add and remove to and from the end, and we can index it. So I want to implement a class that provides those methods. So let's look at what it would take. So we have, we declare a class that way. We make a public class called myList. What else is going to have to go into this class to make this sort of thing even compile, let alone work? Yeah?
We'll need to import the class where we define myList.
Well, Well, we're in my list right now, so no need to import anything.
We need to define miles then.
Well, so the question is, what goes into defining? What kinds of things, when I scroll the screen up, what are you going to find down below here?
Constructor?
Yeah.
Constructor instance variables?
Okay, you'll find instance variables. We'll have to decide on instance variables. You're also going to see a constructor. What else are you going to see? Yeah.
Methods to use on my list.
These methods. You'll see an add method, a get method, a set method, a size method, and a remove method to make that all work. So when you're implementing a class, so typically what I'll do is, in this course at least, is I'll give you a class, and maybe I'll even give you the declarations, the headers for all the methods it contains. Once you understand what services the class provides, what kinds of objects it provides, so you have to understand what they are. So this is how you understand what there are. There has to be a Java comment that explains what these objects are. So it says a simple dynamic list of integers. A MyList contains 0 or more integers that can be accessed and changed via a 0-based index. It is possible to add new elements to the end, to remove elements from the end. So that's sort of, I could have gone on and been more specific, but that sort of tells you what kind of objects to expect. Once you understand the objects that are provided and you have specified all these, all the classes, all the methods and all the constructors, a very important piece of design work starts, and that is deciding how to represent, deciding on instance variables, deciding what instance variables you need for each object to keep track of what you need to keep track of. So every object needs to look, every MyList object needs to look to the user like a MyList object. The user doesn't care what's inside it. The user doesn't look at the instance variables, but you're going to be using them when you write your methods. So in the case of the coord class, we decided we needed 2 doubles. If we had 2 doubles, we could keep track of all the information we needed for a single coordinate. Think about it for a second. What do we need to store inside every MyList object in order to have a chance of providing all the services we've advertised? I want you to think about it for at least 30 seconds. Right? This is the key part of implementing a class, is deciding how am I going to represent the data. So you're coming up with a plan to decide what does each object need to contain in order to be able to have these capabilities that I've designed. Now the simple answer is, let's just put an array list inside it. Would that work? If the instance variable was an array list of integers? Yeah, it would be a very simple implementation, but I don't want to do that. I'm not willing to go that far. So let's pretend we're in a world with no array lists. What should we use? Yeah? Okay. She suggested a string of integers. So we could have a string, and what's your idea? What would the string contain? What you have to think about is, suppose you want to create an empty MyList. What would that string look like at that point? How would you represent an empty MyList with a string? With an empty string, perhaps? Okay. Now suppose you add a number to the MyList. What should happen to that string? Just append the number to the string?
Yeah.
Okay. So that would mean something like, maybe after you've added 3 and 5 and 12, maybe your string looks like that. Right, let's go with this. So the constructor would just store an empty string. There'd be an instance variable called number string. The constructor would just store an empty string into number string. What would the code for add look like? If you have to add something to the MyList, what would you do to the string? Yeah?
You can append it.
You just append something to the string. What about if you want to remove something? Yeah? Yeah, you would basically grab the substring here, and that would get rid of the 12. What about if you had to find the element at index 2? How could you do that? Someone says, give me the element index 2, yeah.
Could you do it like comma-separated values? And
Well, but there are no comma-separated values here. It's got spaces.
okay, so we'll use spaces instead of commas,
Mhm.
essentially. We could create a loop
Okay?
which would assign a variable, well, a number for each occurrence, and then we could just say we want the one that happened to be 2.
Okay. So he suggested a way of using a loop. What occurs to me is just take this string, create a scanner from it, and then if you need the second element, you do next int, next int, next int, and there's the second element, or element 2 rather, element index 2. So you could pull it apart with a scanner. So we could make this work. We could make a string look to the outside world like it's a list. Let's try that. That hadn't been my plan. So my plan had been to use an array, but I'm going to do this. This is a nice idea. I'm going to copy. I'm going to do some renaming here. So I have a couple of different implementations. I'm going to call this one list 3. And then I'm going to copy this one and paste it back in here as list 2. And then we'll work on my list. So let's go with her idea. The idea was string number list. So what we're claiming now is any object, you go find any MyList object, you look inside it, you're going to find a string called number list. And we need to make it private. Now, this comment right here has to explain our strategy, our representation strategy. If you can't describe, you need to be, someone that reads this description has to, there should be enough detail so anyone that reads this description can understand, given a list, what string represents it, and given a string, what list is it. You need to be able to go back and forth from the abstract view of a list, a MyList, and the concrete view of a string. So what would be the right thing to describe it? How would you describe a number list? Yeah?
It's a string with each entered number separated by a space.
Okay. Contains the numbers from the list appended together, separated by spaces. Okay? We ought to say something about the order of the numbers. Okay, the numbers are ordered left to right by index. And then it's good to give some examples. So the string 146 represents what list? What list is 147?
1,4,7.
Yeah, it's this list. Okay? And what about this one? What does the empty string represent? That's the empty list. Let's put it this way. Okay, we could say more, but hopefully we get the idea. So you look inside one of our objects, you're going to find a string, but to the user, the outside world, it behaves like a list. That's what happens if you implement a class. You have to make something that's a string in this case behave like a list. All right, let's write the code. There's some test cases, by the way. Let's see if we pass any of them. So this is list 1. So here's my test. We'll run them. No, we passed 1. Okay, that's sort of an accident. Okay, this is why we passed 1. One of them tested to see what the size of an empty list was, and I just happened to be returning 0 in my stub. Okay, so here's the constructor. It's supposed to create an empty list. So basically given an object that needs to initialize it so it represents the empty list. What do? Constructor, think of it, one of its main job is to initialize the instance variables. Yeah?
New number list equals empty string.
Right. We agreed that the empty list would be represented by an empty string. Okay? So that's good. Okay, what about the get method? Well, let's skip the get method. Let's do the add method. Someone says, add a number to the end of the string, to the end of the list. Yeah?
The number list plus equals whatever that int value is that they put in, so plus equals that.
Okay, so I'll write it slightly differently. Number list equals number list plus a space plus the value. Right? So whenever someone gives us a number to append, we just append it to add to the list. We append it to the string. Yeah?
Well, would you maybe do the val before the empty space? Because that's going to start off with an empty space, right?
Okay. So we got the problem is it's going to start the string with an empty space.
I don't know if that's a problem.
Yeah. We don't want to put the val first because they have to be in order so we can do the indexing. So how can we solve this? We could say something like if number list dot size is 0. So if there's nothing, if the string is empty, then we just say it's just a cheap way to turn it to a string. We append it to the empty string. Else we do that.
You didn't put a space for an empty string.
Pardon?
Under the if statement, you did val plus an empty string instead of a space. Oh, never mind. Sorry.
Yeah, sometimes it's length, sometimes it's size, sometimes it's other things. But yeah, that's how you get the length of a list, of a string rather. Okay? So if someone gives us a number, if there isn't already something in the list, that just becomes the string. Otherwise, we add something to the end. All right? How do we remove the last element of a list? What's your idea?
First, we need to find how long the list is. Then, starting from the last element, we can go backwards to the first white space. And
Okay.
then from there, we can just delete whatever's right of that.
Okay. So there's really a couple cases. So first of all, let's say if number list dot length is 0, what should we do?
So array index out of bound exception.
Right, we throw this exception right here. So that's just what it said in the spec, that if the list is empty, we do that, and we know the list is empty if the number list is empty. Otherwise, if this thing here is 1, what does it mean if, no, that's not going to be right. Well, let's try this. I'm going to go back here. What am I doing here? I say if size is equal to 0, instead of asking if the length of the string is equal to 0. What method am I calling here when I say if size is equal to 0? Yeah?
Public int size.
I have that method right up there at the top. Now, you know you have to invoke, when you call a method, you have to invoke it on an object. On what object is size being invoked?
This.
It's being invoked on the same object that remove was being invoked on, i.e. this. So this is just a shorthand for this. So we're just saying if the size of the object you're working on is 0, it'll run this code to find out. We throw an exception. What do we do if the size is 1? So yeah? Well, we have to set to set number list to something. So if there's only one element in our list, what should be the new string that we use to represent the list? The empty string. That's how you represent an empty list. What do we do otherwise? So you've got a list with more than one number in it. You've got to remove, so we got a string with a bunch of numbers appended together. We've got to get rid of the last one. Yeah?
S equals S dot substring from 0 to number list dot length.
Well, you don't know how many digits are in that last number. So we're going to take a substring that starts at 0 and extends to, I'm hoping there's a last index of method. Number list dot substring, I just meant to say. So the idea is, internally, we have some list that's represented this way, 1, 2, 12. We've got to go cut this part off of the list. So we take a substring that starts here and goes to the last space. So that's what that code is saying to do. Yeah?
Would it have been wrong to do length, I heard someone say length minus 1 with that.
Length of what?
The length of number list.
Well, if you take the length of the number list and subtract 1, you're going to get rid of the 2, but you're going to leave this 1 on it. There's a 2-digit number at the end. So you have to find the last space. Yeah?
For does this refer to the same object until you start talking about another object? Like
this always refers to the object on which the method was invoked. Okay? 8 words. The object on which the method was invoked. Get good at those 8 words. It will be on the final. The question will be, in a method, what does this refer to? And the answer is the object on which the method was invoked. People will miss it. All right, now I think I've gone far enough to make my point. Let's just talk now rather than write code. What would it take to find the size of a list? Someone says, okay, give me the size of the list. You've got to turn around and look at a string and figure out the size of the list from that. How would you figure out? How do you know that the size of this is, that this represents a list that contains 3 elements? Yeah?
You count the number of spaces and add 1.
You count the number of spaces and add 1. Except for the empty string. Yeah?
Could you, like, maybe, like, put all the, like, make a scanner, put all the numbers into a new string, and then count the length of the string?
Right. You can use this string, create a scanner from it, and see how many tokens it contains. That's the size of the list. Okay? Either way, you got a loop. Okay? What about getting an element a specific index? Suppose when someone says, give me the thing at index 1. What would you have to do?
You have to do the same thing and invoke the index.
Right. You could build a scanner, call getNext once, that'll give you the index 0. Call it again, that gives you index 1. It involves a loop as well. So we could make this work. We could use a string to represent lists and implement all these operations. And then to the person in the outside world that's using it, they'd be none the wiser. They won't know there's a string inside the object. They just know it behaves like a list. And the rule here is if it walks like a duck and it quacks like a duck, it's a duck. If the size method works and the get method works and the set method works and so on, it's a list. Doesn't matter what's inside it. However, you may be thinking at some point that maybe this wasn't the wisest way to represent a list. I don't mean to disparage your decision, but often it turns out that you go to implement a class, you decide how you're going to represent it, and you get partway into coding it, and you start to realize, oh man, this is harder than I thought. I'm having to write loops to find out how long the thing is. I'm working too hard. At that point, what should you do?
Find an easier way to do.
Okay, so this is what students usually do at this point. They call over a TA, and the TA goes, why are you using a string to represent a list? It's just going to be too complicated. You're going to be better off if you just back up, pick a better way to represent a list, and then all your methods are simpler. Students won't do that. Students are absolutely opposed to deleting any code they've written. I think the code is just too hard won. They spent too much time on it. They don't want to give up on it. But that's the thing to do. Sometimes you realize you made a mistake. It's going to be painful to push it through to the end. So you back up and try something different. There's something very simple we could do to at least make size work easily. How could we change the representation here to make size work? Make it easy to find out the size. Yeah?
Make an array list?
Well, no, we're not going to use an array list. That's just... Yeah?
Can you use an array?
Well, we could use an array, but let's keep the number list. Let's add another instance variable. There's no rule that says we have to use one. Yeah?
Create an instance integer that keeps track of how many elements you have as you add them.
Right. So what we could do is you say, you know, I don't want to have to iterate through a string to find out how long the list is. Let's just store right here, private int count. And this is just the size of the list. I don't know what I did there. Size of the list. All right? Now, we got back. What do we have to change in the constructor? We have to initialize both instance variables. Well, what should the value of count be? You're creating an empty list.
0.
0. Okay? You add an element. What happens to count? Count goes up by 1. You remove an element. What happens to count? Count minus minus. Someone asks you for the size of the list. What do you say? What do you return? Count. Okay. So we don't have to write a loop for size. Yeah?
If it's already empty and you're calling the remove, wouldn't you the count become -1 since it's outside of all the ifs?
Well, what would happen if you called it and the size was 0? It throws the exception, the method's over. It wouldn't get a chance to decrement the count. But you're right to ask the question. Okay, so we made the representation a little more complicated, but it made keeping track of the count a lot simpler. You don't have to have a scanner loop to figure out how many elements are in the list. We're still going to have loops to deal with things like getting and setting. Okay? We could soldier on. I'm curious to see if we pass any tests yet. So let's. Yeah, we passed 3 tests now. But at this point, I'm going to say let's back up and use the representation I originally intended. Let's take a break and we'll look at that. All right, let's get started again. We just went partway to implementing our class using a string as representation, and hopefully you see that we could have pushed it through. But it occurred to me as we did it that there has to be a better way. That's often the case. In fact, when you take 2420, you spend time exploring different ways of representing common kinds of classes, like lists and maps and sets and such. So what I want to do now is instead of keeping all of our integers in a string, let's just keep them in an array. And in fact, that's what the array list class does. If you cut open an array list, one of the instance variables would be an array that contains the elements of the array list. So remember an array list can grow and shrink dynamically. internally, there's an array which can't grow and shrink. But the code is written to sort of mask that. So we're going to look at doing it with an array. So you notice I have an instance variable now called data. And it says it holds the element of the list. It's exactly the same length as the list. And element I of the list is stored in element I in data. So the list 1, 2, 3 would be stored in an array that contains 1, 2, 3. Very direct representation. Let's see how far we can get with this. What do we have to do in the constructor to create an empty list? So we got to set data to something that stands for the empty list. So what array stands for the empty list? Yeah?
An empty array.
An empty array. So we'll create an empty array. That's what it says. You should be able to look up here, this comment. This is a very important comment. It describes your representation strategy. And it says it's exactly the same length as a list. So that doesn't leave any room for interpretation. An empty list to be represented with an empty array. Okay, that's good. So we've got an empty array. Now, let's pick some easy ones first. Someone says, ask a size for its list. So you've got to figure out what size the list is by looking at the array. So someone asks the size, what do we tell them? We ask the array its size. Every array knows its length. So we just report back the length of that array. Now, someone says, get the thing that's stored at this index in the list. Well, how are we going to figure out what that is? Yeah?
Data with the index in the brackets.
Right. Now, why is this so simple? Yeah?
Because as long as you're not adding things, an array list might as well be an array.
Okay, so what he said was, other than adding and removing, I'll add. So other than adding and removing, an array list is an array. So, and we've adopted a representation strategy that says that the array is exactly as long as the list it represents. And, the thing that's supposed to be stored at index 0 of the list is going to be stored at index 0 of the array. So that's not surprising. What about this thing that says if the index is invalid, throws an array index out of bounds exception? So what if someone says, give me the thing stored at index -1 of a list? Have we taken care of throwing the exception? Now, there's general murmuring, but what's the answer?
I think the data, since you're using an array, that does it itself.
Yeah, the array will do that for us. If we try to get index -1 of the array, it will throw the array index out of bounds exception, and we can just let it propagate. So we're getting so much advantage from using an array. Okay, it's just a lot more direct representation. What about set? Someone says, okay, change what's stored at the given index of my array, change it to val, of my list, change it to val. How do we do that? Yeah?
Int within brackets index equals val. So I mean data within brackets.
There we go.
Yeah, sorry.
Data subindex equals val. It's just another array manipulation. So that's all pretty easy. Now if we go see how we're doing on my tests, need to get the test up. Let's see how we're doing so far. All right, I passed some. 3, I think. That brings us now to what are going to be the harder ones. Add and remove. So, someone says, okay, add an element to the end of the list. And we have to go, okay, I've got to somehow modify the array so that it has an extra element. Can you modify an array so that it's now 1 element longer than it was before?
No.
No. Arrays can't grow or shrink. That's why we have array lists. But we have got to make this, the array that's stored right here. No, not number list, data. Sorry. Data has to change. It has to become an array that's 1 bigger. So how are we going to do that? Okay?
You make a new array with all of the same content as data with addition to the new.
Right. So if internally we have an array that contains A 6, 4, and we've got to append a 7 to this thing. Well, there's no append operation. We have to, you know, data right now is referencing that array. What we have to do is make a new array that contains the new value and then change data so it points to it. Then we throw the old array away. This is an expensive operation. Right? Imagine if this were 1,000 elements long. We'd have to copy it into a new array and add one, add an element at the end. So we've got to build a new array. Now, that sounds like we've got to create a new array that's one longer and then write a loop to copy the elements from the old array into the new one. But fortunately, there's a nice little method that will save us some time. It is called copy of. And what it does is it takes an array such as data and it takes a desired length. And it makes, well, how long do we want the new array to be?
Data.length.
Yeah, one longer than data is. So when you call copy of that way, it makes a new array that's one longer than the old one, and then it copies all the elements from the old one into the new one, and then that last element is uninitialized. So it takes care of the allocating and the copying and everything. So we create a new array and everything gets copied over. Then what do? What's left to do? Yeah?
You add the integer value to the last slot.
Yeah. Now we got it copied over now, except there's probably, by default, there'll be a 0 stored there. We've got to store the new value we care about right there in the new array. So we say data sub something equals val. Well, what is the something here?
Data.length minus 1.
All right, the last index is data.length minus 1. Okay? So we're just, to add an element, we got no choice but to make a new array that's bigger, copy the old elements in, put the new element at the end of the new array. Let's see if that helps us at all. Okay? Everything's working now except remove. Well, what's it going to take to remove? Do we have any choice? What's our representation strategy say? If someone says remove an element from a list, what do we do?
To remove that they specified, like the number.
Well, we got to get a new array that's one shorter than the old one. Right? We've got to cut off an element. And also we got to be sure, let's take care of this first. If size is 0, we'll throw this exception, which may not be the best named exception for this case, but whatever. So if it's empty, we throw an exception. Otherwise, well, how are we going to copy? We've got to take the array that we have, make one that's one shorter, and copy everything over except the last element. How do we do that? Well, fortunately, there's copy of. We give it this, and we tell it the new length that we want is data.length minus 1. It turns out in this case it does exactly what we want. If you don't do that, so now I think still need a semicolon just there. All right, let's run the test cases. Yay. Yeah?
So why in this case is it taking out the whole 17 rather than just the 7? In this case here.
Before, with a string, it's just a string of characters. This array is not an array of characters, it's an array of ints. This is just one int. Yeah?
Is there any ways like doing a move operation like you would do in C where you allocate a memory space going line and then move it over without having to do copy?
Oh, well, okay, so essentially he's echoing what I said before. This is pretty expensive because we got to do an expensive copy every time. And he's suggesting an alternative strategy, which is, well, maybe we just make the array bigger than we need, and when it fills up, then we copy. Okay, we'll try that later. But for right now, I just want to get something that works and is simple. And this works and is simple, or simple enough. Now I'm going to show you a different kind of demonstration in a second. Are there any other questions about this? What was the key thing in getting this implementation? Yeah?
Yeah.
Yeah, picking a good representation. So I started out on the string representation, and I think by the time I quit with that string representation, a lot of you are going, oh man, I don't know what's going on. Hope you stop soon. And I did. We realized, this wasn't the best choice. And things got a lot easier once we used an array. Let me just show you the tests. The tests are things like this. Create a list and try to get an element from it, an empty list, and you expect the exception. Or create a list, add a 7 to it, get the element 0 from the list and assert that it's 7. So these are all operations on lists. You won't see anything about arrays or strings in here. And you can use exactly the same tests for both versions of lists that we've used today. What makes that possible? They use very different representations. Why can we use the same tests? Yeah?
Because, like you said, our implementation doesn't matter as long as the way we output it is the same.
Okay, he said,
the way it's stored internally, it's all like private fields.
As long as it looks and quacks like a duck, it's a duck. Now, they have very different instance variables, the two implementations. Why doesn't that affect the way the duck looks? Yeah?
We write our methods differently to accommodate for that.
Well, we changed the method implementations, but why? What was the key? What's the key? Yeah.
Didn't we name the methods the same?
The methods are named the same. Yeah. So that's the looking like a duck part. The classes are called the same thing. The methods are called the same thing. They take the same number of parameters. They've got the same specifications. But there's a difference. One has a string as an instance variable and an integer. The other has an array. That looks like a difference. Why is that difference not visible? Yeah? Because they're private. If they weren't private, suddenly people would be accessing them. They'd be saying, I'm not going to use the add method. I'm just going to go modify this array. And you don't want your programmers doing that because, first of all, it's hard. Second of all, you may be a huge success and you have 1 million users for your class and you decide, I'm going to make it more efficient. I'm going to change the representation. If your instance variables weren't private to start with, people are depending on them now and you won't be able to make the change. So for forwards and backwards compatibility, that's why instance variables are private. The fundamental reason you make them private is so you can change them in the future. No one's depending on them. Okay, so let's look at this. So I want to give you an idea of what goes on in the memory of your computer when a program runs. This is our first look at the Java memory model. And my strategy is this. The more ways you have of looking at something, the better chance you have of understanding it. So we've been looking at the problem of implementing array lists sort of from an abstract viewpoint. You've just got to somehow conjure up a representation and some code in the methods that makes the thing behave like a list, even though it's really an array. This is another way of looking at it. Let's look and see what happens when the program runs. So what I showed you here is you see the instance variable data, and you see the constructor that we wrote. I want to show you what happens when you execute that line of code up there. When you say, you create a new variable called list, and you store in it an empty mylist, a new mylist. Okay, and the first thing I'm going to do is change I'm going to replace data with this dot data just to emphasize that that really is a parameter. It's just you don't see it very often. So I'm going to put it there so it's in your face. Now, what we have on the left is called a stack. And basically, when a method runs, it gets space on the stack to store its variables. And so that piece of code is in some method, and that method is using a piece of the stack to store lists. And the way it works, we'll look at a more detailed diagram in the future, is the area where the variables of a method are stored on the stack is called a stack frame. And as you call methods, stack frames are added to the stack. They're pushed onto the stack. As methods return, they're popped off the stack. Do you ever see this in the Java debugger?
Yeah.
Yeah, in the Java debugger, for each method, you're seeing its stack frame. You saw that in the lab. So you set a breakpoint in a method. When it reaches the breakpoint, you can look at the stack frame for that. It will show you all the variables and what their values are. Well, they're actually stored in memory somewhere, and the place they're stored is called the stack. So when this is all done, in addition to that, right next to the variable called list, we're going to store its value. What will its value be? What will be stored next to list when we're finished executing that line of code up there? He said a new int array. Okay, not quite right.
New mylist object.
He said a new mylist object. That's a lot closer.
This.
Yeah?
This.
Maybe not ID for the list.
Okay, he said an ID for the list. ID is sort of an Eclipse thing. So what you'll have is a reference to a list. So objects are never stored directly. They're stored indirectly via a reference. So you'll see an arrow in my case. So Eclipse doesn't draw arrows, it uses IDs. I'm just drawing arrows here. Okay, so you've got the code of the constructor there. What's the first thing that has to happen in order to create a new mylist? What's the first step, even before the constructor is called? Yeah? Hmm?
You have to write the new keyword?
Well, you have to write the new keyword, but when this thing runs, what's going to change about this picture? What has to be accomplished? Yeah?
Allocate space for the instance.
Right. You have to allocate space for the object. Objects go not on the stack. Objects go over here in the rest of memory. That's called the heap. So you've got the stack and the heap. Okay? So when we say new mylist, we've got to allocate space for the new object on the heap. Now, how much space do we need? What does a new list? What does a mylist object contain? Yeah?
An empty int array.
It has to contain a reference to an empty array. It's got to have room for a reference to an empty array. So the new part of that, the new mylist part, you end up like that. You create new, the new will create an empty object and will have a reference to it. Now what has to happen? What has to be done to create the list besides just creating the object? Yeah?
Storing the object's values.
Well, he said storing the object's values, in other words, initializing data. But what does that? Yeah?
The constructor?
The constructor. The constructor has to be called. So we call the constructor. Now, the constructor is going to have some variables on the stack as well. It will be up above the variables for where we are right now. What parameters does the constructor take? What parameters does the constructor take?
None.
Well, I don't see any, but it really takes one.
Oh, this.
Right. The constructor needs to have a reference to an object to initialize. And so I denote it that way. The constructor will store on this, before the constructor is called, as the constructor is being called, there'll be a variable called this that the constructor can access, and it will refer to that object right there. So as the constructor is running, it needs to know what this is. It looks in its stack frame and sees, it's that object over there. Okay, so now the constructor is running. It has access to this. What's the constructor going to do? What's going to change about my picture now? Yeah? Right, it's going to store a reference to an array up there next to data. So you get that picture. And I put that to indicate it's an array of length 0. So this refers to an object. The object contains a reference to an empty array. Okay? Now the constructor is going to return. And when a constructor or method returns, its memory is taken off the stack. So what will happen when I hit my space bar? Yeah?
It'll only be list that points to data and not 0.
Right. So right now, this and list are both pointing to data. And you saw that in the lab last time, that if you look at different stack frames, they contain the same ID. They're both different stack frames can be referring to the same object. So I return from the constructor, and what's left behind is now this refers to initialized myList object. Say, from the point of view of this variable right here, it's referring to a list. Well, inside the list object, there's a reference to an array. So that's how the constructor works. Now, I'm about to show you what happens when we make a method call. But let me see if I can answer any questions here. Nothing will make you a better programmer faster than understanding this memory model. If you leave this class able to create diagrams like this, you will have such a huge advantage over everyone else that can't. I run into students all the time in upper division classes that struggle with this sort of thing. So it's not easy, but it really pays off. This model is used across languages. It's not like just Java's memory model. This idea of a stack and a heap and references. So it is really worth trying to understand what's going on. Yeah?
Well, which part of this diagram is the heap?
Everything that's not the stack. So if you think of the slide up there as being memory, you sort of got to ignore the other words I wrote on it. But if you ignore my box there in the title, the whole slide is all of memory that the process has. Then that is the stack and everything else is the heap.
The stack has like all the variables?
The stack contains variables, yes. Parameters, the methods, and local variables. And they either have, if primitive values are stored directly on the stack, references are into the heap. Yep?
How is stack versus heap memory allocated?
Well, typically when your Java starts, it has a certain amount of memory it can play with. It allocates some of that to the heap, some of that to the stack, and some to the heap. Stack memory is just allocated very systematically because methods call, return, 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 return. So just imagine you've got the stack grows and shrinks. Heap memory is allocated just sort of, there's a manager that looks for free space and puts objects in them.
Okay.
A lot less efficient. Yeah?
So the stack refers to the variable data that refers to the...
Well, the stack is this box. The stack contains a variable whose value is a reference. Yeah?
So this is a variable. So can you explain the dot after this dot data? That means
okay.
Like a sign.
So what happens right here, this line of code, is the constructor says, I need this. Well, it knows this is stored in its stack frame. Well, it's not there now, but. So the constructor says, let me go find this. It goes to its stack frame and finds it. It says, okay, data. It says, okay, I need to follow the arrow to an object, and there'll be a data field there. And then it says you need to create a new array and store it there. And so the constructor does that.
So this dot data means I store the index of variable data to this.
Well, this dot data just means this is an object. Data is an instance variable of the object. And as a value of that instance variable, we store an empty array.
Okay. this is an object which storing the variable in the stack.
This is a reference to the object being constructed. In this case, you see list and this refer to the same object. Okay? Like I say, I don't expect, people aren't going to get all this the first day. And we'll come back to it. But as you gradually get familiar with it, it'll work. Yeah?
So the order in which you put things in the stack matters? Or?
Yeah. So I didn't put enough detail in here, but basically, you got your stack. Let's say it grows in this direction. The main method stores its variables there. Main calls another method, its variables go here. That calls another method, its variables go there. That first method returns, its variables come off the stack. So it just grows and shrinks, and then when the program ends, the main method returns and everything's gone. It's just an efficient way of keeping track of variables. Yeah?
In the stack it says list. Is list referring to my list?
There's a line of code we're executing. List is that variable up there
Okay.
that we declared as a my list. Yeah?
Okay, so you can have multiple things in the heap calling other things.
Referring to other things, yeah.
So it could be infinitely recursive, assuming the...
You can have cycles. You can have an object that refers to itself.
Okay.
Okay, so that's the state of affairs right here after the constructor returns. Now let's execute that line of code up there. List.add. We're going to add 5 to the list. So the first thing we have to do, the first thing we do is we call the method add. How many parameters does add take? 1 plus this. So what should the initial value, so there's val, what should the initial value of val be? 5. We're passing 5 as a parameter. What should the initial value of this be? It should refer to the object on which the method add was invoked. Well, on what object is add being invoked? List. So this ought to refer to the same thing as list. So I've added the thises to that just so you can see. We'll make the implicit parameter explicit. There's the stack frame for add. Val gets a 5 because that's what it said to pass to it, that 5. Well, I don't have it there yet. Val gets the 5, and this refers to the same thing as list. This refers to the object on which the method was invoked. Now this code can run, and when it needs to look up this, it can look in the stack frame and find it. When it needs to look up val, it can look in its stack frame and find it. Yeah?
So we can think of this as basically just list, but in another place in the stack frame. It's the same exact thing.
Yeah. I mean, there are 2 different locations in the stack, but they refer to the same thing.
Okay.
And you saw this in the lab, except it was with ID numbers. So when 2 variables referred to the same list, they just held the same ID number. All right, well, let's step through it. What's going to happen with this first assignment? How will the picture change? I mean, what it has to do is it needs to call arrays.copyof, so it needs to find this.data. How does it do that? Dot just means follow an arrow. So how does it find this? Where does it find this? In its stack frame. It follows the arrow, and it needs data, so that's the value of data is that arrow to the array. So this.data is the arrow, is the reference to that array. That's one parameter. How does it get this.data.length?
Follows the arrow from data to length.
This to data, data to the array, the length field is 0. So it passes the reference to data and 1, 0 plus 1, to the method arrays.copyof. Now I haven't animated that method call, but it would have its own stack frame. It's going to return a new array that's 1 bigger. What's going to change about my picture? What are we doing with that array that comes back from arrays.copyof?
We're assigning it to this.
We're storing it, no, we're not assigning it to this.
This.data.
We're storing it back into this.data, so the picture looks like that. That shows you, that's what's returned by the call to arrays.copyof, and we store a reference to it in data. So see what happened. A minute before we did that assignment, data was referring to that array, now refers to that array. So that's what add did. Now, what's going to happen to that orphaned array there of length 0? It's going to hang out in memory until the garbage collector runs. And the garbage collector runs periodically and finds unused objects and removes them from the heap. I'll just remove it right now. So eventually it'll disappear. If it's not referred to by anything, there's no need for it. Okay? So add has modified, add works on this and val. It goes out and makes changes. What's going to happen now? What's going to look like when add returns? How will the picture change when the method returns? Yeah? Right, so the stack frame that contains val and this is popped, and you're just left with that. So from the point of view of the caller, at one instant, if you just did a step over, instead of stepping into the call to the method, at one point we were in that situation, and now all of a sudden, we're in that situation. So add went and modified that object up there, and the effect was having it point to a new place. Yeah?
So this program adds something to the length of data, and then it places the value that was put in through the parameter at the first part of the list?
Yeah, I mean, basically.
I'm just trying to understand this.
Yeah, the length of an array is automatically maintained by the array. The bigger point is we made a copy of the old array and now stored a reference to the new array in data. The old array went away. Okay? All right. I hope you have a great fall break. After fall break, on the Monday lecture, we're going to finish up these. I have one more example to show you, and then we'll do a review for the midterm.
Oh yeah, fall breaks.